So in this section, we're going to go over complex numbers because we're going to see these come up in the next two methods that we look at for solving quadratic equations. And we kind of went over negative square roots, which is our I unit, which is the imaginary unit. So today we're going to kind of go more over that and what a complex number is, which is a mixture of the real, a real unit and an imaginary unit. So imaginary unit, like I said, is that square root of -1, which equals I, and we kind of went through that. So a pure imaginary number would be one that doesn't, when you simplify it, so like the square root of -25 would be -5i. So it doesn't have a square root left over. A complex number would be one that has both a real unit, like maybe 6, and an imaginary unit. So we have our real and we have our imaginary. So when we talk about the reason, or we've talked about this, but I squared is -1, and so we see this power of i's that happens. So the power of I, the first I to the power of 1 is I to the power of 2 is -1 because I squared is -1. I to the power of 3 is I squared times I, so I squared is -1, and times I would give me -I. And then I to the fourth is I squared times I squared, which I squared is -1, times -1 gives me 1. And then it kind of goes back into that same cycle. I to the fifth is I to the fourth, which we just said was 1, times I, which is 1i or I. So it kind of goes back in here. I to the sixth is I to the fourth times I squared, which this is 1, and this is -1. When I multiply it, I get -1. So everything goes right back through that cycle. So every 4 i's, it goes through that cycle again. So that is kind of that power of I cycle. So we're going to divide the exponent by 4, and if there is no remainder, the answer is 1. If there is a remainder of 1, the answer is I, and if there is a remainder of 2, the answer is -1, and if there's a remainder of 3, the answer is -I. So I could find this by taking 23, divide it by 4. 4 goes in there 5 times, and I have, remember this in elementary, 3 remainder. So this is the same as I to the third, which is a -I, because I squared is -1 and times I is -I. So 2006 divided by 4, we'll only really care about the remainder, but 4 goes in there 5 times, which is 20, 0, 0. Bring down your 0. Hopefully you're kind of remembering your division rules. Divide by 4, you get 1. Remainder of 2. So this is the same as I squared, which equals -1. And you just keep going. 37 divided by 4 is 9, which is 36, which is a remainder of 1. And that is just I, or I to the 1, which is I. And then same with 828 is divided by 4, 207, remainder of 0, so this would just be 1. Alright, so that is the power of i's. You do have a section on that, just kind of want to know that. And let's look then at, we did square root, so I'm not going to go through that again. What we're working with I. So if I multiply pure imaginary I, so these are just I units, you're going to multiply my numbers. -3 times 2 is -6. I times I is I squared. And then you're going to simplify your I squared to remember I squared equals -1. So then I multiply my -6 and -1 and I get 6. So it works a little bit different than multiplying by negatives, because each of them have a part of a -1 in it, kind of, you could say. So this you wouldn't multiply first, you would take your I out. So I'd simplify this to square root of -1, square root of 4, square root of 3, which this is I and this is 2 and square root of 3. And I would simplify this to I square root of 2. Then I'm going to multiply. So you want to simplify first on the square roots. So 2I times I is 2I squared. Square root of 3 times square root of 2 is 3 times 2, square root of 6. And then I squared is -1, so 2 times -1. Square root of 6 is a -2, square root of 6. So you want to do your I simplify first and then multiply, which in real numbers we would do opposite. So try this one and then check to see if you get the right answer. I'd pause the video and go through that. All right, so let's talk about complex numbers, because this is what our answers are going to look like on some of these. So my complex numbers are going to have a real unit and an imaginary unit. So when we're working with these and adding them and subtracting them, we're really multiplying, we're adding and subtracting the real units and then the imaginary units. So for this 2x plus yi to equal this -14 minus 3i, then 2x has to equal -14. So 2x equals a -14. Solve for x equals -7, and y has to equal -3 for them to be equal. So those are the two values that would make that equation true. So kind of doing a lot of little things here. So again, I would pause the video, try this, and then work it out. Pretty easy. Put 3x equal to 15 and -y equal to 2 and solve out for x and y. All right, so let's look at the operation with complex numbers. So adding them, you're going to add the imaginary units and you're going to add the real units and add the imaginary units. So I'm going to do 3 plus 2 for my imaginary units. I'm going to just put a plus here. 5 minus 4 for my imaginary units, and I get 5 plus 1i, or just 5 plus I. Same with subtraction, you're going to subtract your real units, so 4 minus 3, and I'm going to again just put a plus there just to hold that, and then -6 minus a -7i, so I get 1 plus 2 negatives make a positive, 1i, or 1 plus I. And multiplication is kind of like the same as if I multiplied this like a 4 plus 3x and a 7 plus a 2x. It's the same process. You're going to multiply the 4 to both terms, and then you're going to multiply the 3x to both terms. So same thing, 4 to 7 and 4 to 2i, and then 3i to 7, 3i times 7, and then 3i times 2i. So everybody gets multiplied, and you see that FOIL man that I talked about in class, if you've been in class for that. So I'm going to go 4 times 7, 4 times 2i, and then I'm going to go 3i times 7 and 3i times 2i. So I get 28 plus 8i plus 21i plus 6i squared. So 28, put these two i's together because they're both I imaginary numbers. So plus 10i, and then 6 times I squared is the same as 6 times negative 1, so minus 6. Then I can put these two real numbers together. So 28 minus 6 is 22 plus 10i. Another way that I like to look at multiplying these is, so this is, well, I'll look at it. We'll look at it with this one, but this is like an example of where you see this. I think I've talked about this a few times. We see complex units and numbers used a lot with electricity. Of course, I'm not an electrician, but they're going to represent like a J here in electricity, but they work the same way. So if I'm trying to find my electrical voltage, I would multiply I times Z. So I is going to be, we're finding the voltage, I is going to be my current, so 1 plus 4J, which I'm going to kind of think of as an I, or not kind of, I am, and then times 3 minus 6J. So I also like to line them up here so then I can see that multiplication. So 3 times 1 is 3, 3 times 4J is 12J, and then do negative 6 times 1 is negative 6J, and put that right underneath there, and negative 6 times 4J is a negative 24J squared. So again, this is 3, 12 minus 6 is 6, and then my J squared is still a negative 1, so plus 24, and then put my 24 and 3 together, so 27 plus 6J. So that is what we're going to look at right now. Later on, we'll get into dividing complex numbers, but that's why we're going to end right now today. All right, hopefully that makes sense. If you have questions, let me know.